So in this video, we want to look at representing inequality on a number line. So let's look at how we actually represent inequality on a number line. So if we have x is greater than 4, then what we will do, we'll locate our point at x at 4, and then we will open at 4. This simply means it is not equal to 4. It is open at 4. And since it is greater, then it is going in this direction, because all the values that are greater than 4 is heading to that direction. And so that is how we will represent x greater than 4. X is greater than 4. The next one that we look at is x is less than 5. And so we do the same thing, leave it open because it is not equal to 5. And it says it is saying less, so we're going in that direction. So all the numbers going into that direction is actually less than 5. And it also makes this inequality true. Because if you should choose 1, 2, 3, 4, all of those numbers individually are actually less than 5. Let's look at another one. Say we have x is less than or equal to -1. So we'll locate where -1, and since this means equal, it is equal or it is less than, then we'll actually shade here. We close it because it can actually be 1 or it can be less than 1. And so whenever it is equal, or, then we must shade there. Let's look at another one. If I have x is greater than -3, so what we'll do, we'll actually we'll start at -3, and since it says it is equal, x is greater or equal to, and so we'll actually put it right here. So it says greater, that simply means it is heading in that direction. So all the possible values that you can pick, that you can randomly choose from this direction, will actually make this inequality true. Let's look at another one. So say we have -3 x, let's say 3. So this is saying x is greater or equal to -3 and less than or equal to 3. So when we look at this, we're actually seeing that this is actually this has a bone. It is actually it has a limit or a boundary at 2 ends. So let us look at it. It is actually bounded. It will be at 3 right here, close, because it is equal or greater than it. And then we'll go to 3 here, and it will actually bound here. And so we'll actually draw this line. So anywhere between that or exactly at -3 or +3, this will make the inequality true. And we could just randomly choose any one of these numbers. If I should choose 1 and place it where x is, wouldn't 1 be greater than -1 and less than 3? It will actually indeed satisfy that condition. It will be greater than -3, but not equal. It will be greater. 1 will be greater than -3. And also it will be less than 3. So any one of these numbers that you pick, you'd actually make the inequality true. If you should pick even 0 and place it right here, 0 is greater than -3 and less than 3. What if you want to choose 3? You could put 3 right here. So you could say 3 is greater than -3 and what? Equal to 3. So 3 would actually work. And even if we should choose negative 3, this would be saying negative 3 is equal to negative 3 and less than 3. So any one of these numbers that you choose that is actually confined to these boundaries, it will actually make the inequality true. Let's look at another one. Let's say we have 2 that x is greater or equal to 2, and what? I'd say less than 3. And so we actually go where 2 is, we close it at 2 because it is actually equal or greater. And then we go to 3, but we will not close it at 3 because we don't have it does not say it is equal or less than 3. So it will actually be this. So you can choose any one of these numbers in that interval, and it actually make the inequality true. Now I want you to try this one on your own, and then let's see what you got. If you have -1 x, I said that. So pause the video and give yourself a try. Alright, so let us see what we have here. So it is saying x is greater than -1, so we will leave it there open, and it is heading to 3, and so it will actually be closed at 3. So you could choose any one of those numbers between greater than -1, but at least, greater than -1 or exactly up to 3 or below 3. So let's look at another one. So let's try, I'm trying to remember, did you look at this one? 3x, 3x, and so we'll actually start at 3. Oh, let us add one more number to our number line. Start at 3, close at 3, up to 6, close at 6, and so the boundary or the range would be between those two numbers. And so here, let us look at the last one. So if I have -1, so this is saying that x is greater than -1 and less than 0. So we'll find -1, leave it opened, 0, leave it open, and there it goes. So that's it, representing inequality on a number line. I trust that this video will be of good use and help to you. And remember, share, like, subscribe. See you next time.